Alright, so this is the second video on solving systems of equations or linear equations in three variables. Okay, and so this, I'm not going to lie to you, is probably going to take us a long time to do. Right? I mean, these problems usually take up almost a full sheet of paper, and they take probably 15 minutes. I mean, these are not usually fun problems to do unless you really like algebra. But we got to learn how to do them. They're on the test, but I don't know if they're necessarily hard problems. They're just long problems, and when you have a long problem, what happens is students tend to make more mistakes because there's more chances to make mistakes. And so you really want to take your time and slow down and show all your work, along the way. Okay, and so don't try and conserve paper. Use as much paper as you can. Otherwise, you're going to get sloppy and you're going to make an error and you're going to get the problem wrong. And if you make one small mistake early on the problem, it's going to throw everything else off. And so you don't want to do that. So take your time, use as much paper as you want, and show as much work as you need to, okay, when answering these types of problems. So, here what we have is we have three equations. Here we got, 1, 2, and 3 equations. And what we have to do is we have to solve these, okay? And so when we were solving, systems before, we only had two variables. We had an x and a y. And we have three different methods for solving. We had graphing, substitution, and we had elimination. And so we can use any of those methods. Those will work for this, but there's one method that works, probably better, or when I say better, it's probably the most efficient and will get done the quickest if we use it. And so, the first method is graphing. And so graphing, we were looking for when we had two variables where the two lines intersected. But when you have three variables, you don't have lines. You have actually, these planes that are intersecting. And so we don't know how to graph, equations with three variables, so you can't really use the graphing method. The next method would be substitution, and the substitution method would work for this, but it would probably take you a little bit longer. And so the method that I would recommend to use for these cases most of the time is the elimination method, and that's the one where you add two equations together and then eliminate the variable. Okay, and so that's the way I'm going to show you how to do it. You could use substitution, you could use graphing, but if you knew how to do it, and those will all work. It's just I think the elimination method is the quickest. Okay, and so what we would do is we would take two of these equations and we would add them together. And let's say we eliminated the x's first. We would add them together to eliminate a variable. And if we eliminate a variable, what happens is we still have two variables left. And so that's kind of why this process takes forever, right? Before we would add two equations together, and we would either eliminate the x's and we just have the y left, or we eliminate the y's and we just have the x left, and then we could solve for that variable. But now when we eliminate one variable, we're going to have two variables left over. And so this is what makes the problem longer, okay? And so the first thing I like to do with my equations is to number them so I have an idea, so I can talk about them, right? So I'm going to number all three of these equations. So I'm going to have my first equation, the second equation, and I have my third equation, okay? And so what I'm going to do is I'm going to look at all three of them and see if any of the variables will eliminate rather easily. It doesn't matter which two you pick, but you got to pick two to start with. And I like to pick two that I can maybe eliminate without doing any multiplying. So, for example, if I look at equations number 1 and number 2, I have a positive 4y and a negative 4y. And so if I add those two equations, I add equation 1 to equation 2, I can see that the positive 4y and the negative 4y will cancel out. So what I'm going to do is I'm going to rewrite these over here, and then I'm going to add them together. So I'm going to have 4x plus 4y plus z equals 24. All right, and then I'll write this number 2 equation right underneath it. So I'll have 2x minus 4y plus z equals 0. Okay, and so make sure you write it out accurately. And then I'm going to get a different color here. And what I'm going to do is I'm going to add these together and see what I get. So, 4x plus 2x is 6x. 4y plus negative 4y is 0y, so those go away, and that was the whole point of this. Z plus z is 2z, so I have plus 2z, and then I have 24 plus 0 is just equal to 24, right? And so that's one of my equations, but again, like I said before, we still have two variables, and so now we got to get another equation. So we got to get another equation so we can have an equation with only two variables, another one, so we can do that. So I guess, once you create one of these equations, I'm trying to say that a little more clearly, once you eliminate one variable and have an equation with just two variables left over, you need to create a second equation that has the exact same two variables. So in this case, I have an x and a y because I eliminated, or an x and a z because I eliminated the y. So I need to create another equation with just x and z in it. Okay, and so I can't use, if I use 1 and 2 again, I'll get the exact same equation. So I can't use the combination of equation 1 and 2. What I have to do is I have to use another combination. So I can either use 1 and 3 or 2 and 3. I can't use 1 and 2 because I already used that combination. So I'm going to look at my equations. I can say, well, I have a positive 4y and a negative 4y. So there again, I can see those will cancel out. So now I'm going to use equation 1 and equation 3 to create my new one. Okay? So let's see if I can do that here. I'll have 4x plus 4y plus z equals 24. And then I'll take equation number 3 and put it underneath it. 5x minus 4y minus 5z equals 12. Okay, and what I'm going to do here is get a different color here. I'll use red again. And I'm going to add these two equations together. And so I'll put my add sign here so we know. So 4x plus 5x is 9x. And 4y minus 4y, again, will cancel out those y's. Okay? And then I have, so those go away, and I have 1z minus 5z, which is a negative 4z. Right? And that's equal to 36. Okay? And so just to recap, what we did was we looked at two equations to start with. We looked at equations 1 and 2, and we saw those were easy to eliminate the y's because the y's were opposites of each other, and we eliminated those, and we got down to just having an x, or an equation with x and z in it. And then we said, well, we still have two variables, so we need to create another equation with just x and z in it. But we have to use a new combination of equations. So we chose equations 1 and 3, again, because we saw the y's were opposites of each other. We eliminated the y's, and what we were left with was another equation with just x and z in it. Okay, and so that's where we are right now. So what we're going to do now is we're going to take these two equations, these two red equations, and we're going to eliminate one of the variables in their equation. Okay, and so we're just trying to eliminate variables until we get down to one variable. So we're going to take these two equations, the two red equations, and eliminate one of the variables, either the x or the z. And it doesn't matter, whatever seems easier. And so I look at the x's aren't the same, the z's aren't the same, but what I notice is this is negative 4 and this is a positive 2. So if I multiply this equation by 2, then I'll have a positive 4z and a negative 4z. So what I'm going to do is I'm going to take this equation right here, and I'm going to multiply it by 2. So I get the opposite of this negative 4z, right? So I'm going to have 12x plus 4z equals 48. Okay? And then I'm going to take this equation and write it right underneath. So I'm going to have 9x minus 4z equals 36. Okay? And so what that tells me is it's going to eliminate one more variable. So let's do that right now. I'll use a different color here. Let's add these equations together. 12x plus 9x is what is that? That's 21x. 4z minus 4z is 0. Those go away. And then this is equal to 48 plus 36, so that's going to give me 84. Okay, and so what we've finally done, we've eliminated the y's, then we eliminated the z's, and so now we're left with just the x's. And so now, since I have just one variable left, I can go ahead and solve for x, okay? And so let's solve for x by dividing by 21 on both sides. Okay, and what that gives me is x is equal to 21 goes into 84 4 times. Okay, and so that means x is equal to 4. And so, is the question, are we done? No. We got to find what x is, we need to find what y is, and we need to find what z is. So we know what x is, now we need to find y, and now we got to find z. So we'll do that in the second video.